In this video, we will discuss key considerations when managing a combined retinal detachment. Why these cases are slightly different? Well, in addition to having a tractional component in certain areas of the retina that are already predisposed to detachment, microholes sometimes develop adjacent to these tractional zones. These microholes allow fluid to migrate more extensively into the subretinal space, resulting in this type of detachment. Managing membrane removal in these cases is particularly challenging. In pure tractional detachments, the segmentation of membranes can typically be performed by utilizing the natural support of a flat surface, such as the retina itself. However, in combined detachments, this support is lost. So in such situations, I strongly recommend using a chandelier and performing bimanual dissection to improve control and precision. Here, the detached retina is extremely thin, making it nearly impossible to avoid creating small microholes during manipulation. Don't be discouraged if this happens during the procedure. It's among the challenge in these cases. Remember, the primary goal is to save the eye, as these cases generally carry a very poor visual prognosis. Typically, removing epiretinal membranes is necessary, and even after successfully releasing them, additional steps may be required, such as performing retinotomies to drain subretinal fluid, or in some cases, retinectomies to relax specific areas of the retina and achieve optimal repositioning. Well, we have already discussed the management of tractional retinal detachments, and here, as in those cases, I always recommend starting by releasing or performing a vitrectomy of the peripheral hyaloid before initiating membrane peeling. This provides greater assurance that when manipulating the membranes, you won't induce traction in the peripheral retina, which could lead to uncontrolled or more challenging tears to manage. Observe how, as you begin peeling or shaving the membranes, the slight lifting of the membrane already creates a hole. This is fine. It actually serves as a window to drain the subretinal fluid and helps flatten the retina a bit more. Look at how thick this fluid is. This patient had likely been in this condition for months, if not years, before receiving the treatment. Now, as I mentioned earlier, this is where the chandelier comes into play. There are various types of chandeliers. In this case, I am using a single pole system with just one trocar. When using a single pole chandelier for illumination, carefully choose the direction where you want the light to be focused. Observe the areas of the retina you want to illuminate for manipulation. For example, here I choose to place it superiorly because most of the more challenging membranes are slightly oriented toward the inferior portion, so I want optimal illumination in that area. Try to angle the light pipe at 45 degrees so that it's not completely horizontal within the cavity. If you position it horizontally, it will cause a severe glare from the intraocular lens and you won't be able to see clearly. Now, when performing bimanual dissection, try not to move the eye excessively. While some movement is inevitable, avoid moving it too far from the target area, as this will cause the chandelier to shift and result in a loss of focus and visibility. If this happens, reposition it correctly before continuing to ensure proper visualization of the dissection plane. Using both hands, I generally recommend starting by gently lifting the membrane with retinal forceps to create a slight elevation. This allows you to insert the tip of the retinal scissors and perform an initial blunt dissection. In this way, you can create a virtual space in which you progressively dissect the entire membrane. Pay close attention to the angle or orientation of the membrane. In certain areas, as you will see in the video, particularly nasally, I first introduce part of the scissors and use this technique to cut or segment the membranes. In the video, I have shortened the process as much as possible to save time, but I want to emphasize that this procedure takes time and you must be patient. I aim to share as much of the membrane dissection as possible because it's a crucial part of the objective of this video. Now, as I have mentioned before, you are likely to induce retinal damage while manipulating the membranes. The retina in these cases is extremely ischemic and thin. The goal here is to ensure that the damage is as controlled as possible. If holes are created in these areas due to traction or manipulation, it is likely in regions where the retina was already non-functional. The objective, in a way, is just that, to avoid extending the damage while dissecting as much as possible to enable retinal reattachment. Now, as you can see, most of the damage occurs in the nasal quadrant and ovovascular arcades. Therefore, the primary goal is to preserve the macular area as much as possible. In previous videos, I have mentioned that it's helpful to use diathermy to coagulate areas of fibrovascular membranes to prevent bleeding and maintain clear visualization. However, in this case it is not feasible and I do not recommend it. Applying diathermy to these areas before removing the membranes can cause downward contraction of the detached retina, which may make it more prone to tearing. So if you choose to use diathermy, do so only after the membranes have been removed. Now, as you can see in the video, here we work in sections. I usually recommend to start with the sector that is usually the less complicated one, as this will allow the retina in areas with the thickest membrane, in this case the inferior retina, to become more mobile and less tense. Once the membranes have been segmented, you can now remove them more confidently and easily using the retractor. Once the membranes have been released, I recommend applying heavy liquid to assess how easily the retina flattens with the amount of membrane removed. There are cases where you may need to cut a more extensive area of the retina to relax it and allow proper reattachment. As you can see, once the heavy liquid is applied, an inferior bullous detachment forms. At this point, it's advisable to perform retinotomies to drain this liquid, as the causal breaks are very posterior and especially with the transition to air, it will be difficult for the subretinal fluid to drain by gravity alone. In this case, I perform 2 retinotomies, as there can sometimes be segmentation of fibrosis in the retina, meaning only one side may drain while the other side remains filled with fluid. These retinotomies can be managed without issue once the retina is reattached. Once the heavy liquid is applied, a good tip is to perform an interface vitrectomy, meaning between the heavy liquid bubble and the peripheral retina. This provides great stability and allows for proper shaving in these cases. Observe how the retina has been successfully reattached in its entirety, and the next step is to apply laser around the areas where the membranes were and also perform panretinal photocoagulation. The inferior retinotomies will be partially marked and then under air are fully surrounded with laser. Perform indentation is always a good tip to rule out any peripheral breaks or tears. Now, when you begin the fluid air exchange, position the extrusion tip in one of the inferior peripheral retinotomies. This will prevent fluid from entering from the periphery and later direct it toward the posterior pole. Once the cavity is filled with air and the retina remains attached, you will have a much clearer view of certain peripheral areas. I always recommend applying additional laser in these zones. Similarly, applying laser allows you to confirm that the retina is effectively adhered by observing the laser marks. These cases should always be left with high-density silicone oil. In a future session, we will discuss tips for injecting silicone oil into the vitreous cavity. So that's it. I hope this video is helpful and thank you for watching.